Solve the system of equations. Oh, we have to solve this by graphing. Oh, okay. Well, we can do that pretty straightforwardly online, right? We can just do this. So y minus 26 is equal to negative 6x. And y minus 5x is equal to negative 29. So let's do a little zoom in. Let's see where these things intersect. They're going to intersect here at 5, negative 4. 5, negative 4. Let's do that in black. So those do have an intersection point. Just be mindful of the instructions here. So if the system is inconsistent, we enter D and E in each of the boxes. And if there are an infinite number of solutions, we're going to use a 0, 0 to represent infinity in these boxes. But ours had a nice solution, so we were able to get that solution in. So question 2, consider the following systems of equation and its graph. US and Canada switched a while back. I wonder why they pushed it like so much later. That seems very bizarre. I wonder if there was a reason for them to push it back. That would be my first question. Okay, so consider the following systems. What is the solution to the system? Well, it looks like it's at like negative 3, negative 2, right? Here's the solution. It's this intersection point here. I'm just kind of making a wild guess, but it kind of looks like it's at negative 3 for the x and negative 2 for the y value. And then in part B, we have to determine which is the red and which is the blue. So graph A, red. Which one's the red one? So the red one has a negative slope and the blue one has a positive slope. So this equation, this second equation, negative 2x plus y is equal to 4, should have a positive slope. So the blue line is going to be this one. So let's just pop that in here. So the blue line goes here, the red line goes here. Just based on its slope number. Okay, here's where we're going to have to start solving some stuff. I knew we would have to start doing some substitution eventually. So solve the given linear system of equations. So enter your answer in the form of an ordered pair. And then we also have a little selector here too, right? So we have to actually physically select if there's a solution set or if there's, that's weird, one or more solutions. That seems weird. Or infinite. That's weird that you can go one or more solutions and infinite number of solutions. That seems weird. But let's take a look. So we have 3x minus 9y is negative 15, and we have negative 6x plus 18y is equal to 30. Oh, these seem like they are gonna be multiples of each other. That's what it feels like. Let's go ahead and multiply the first one by 2. If we do that, we get 6x minus 18y is equal to negative 30. And negative 6x plus 18y is equal to 30. So these are redundant. They are the exact same equations, just multiplied by minus 1. So there are actually going to be an infinite number of solutions here, because we should end up getting a 0 equals 0 when I actually subtract these. So if I take these two equations and I subtract them, we basically get 0 equals 0. So I know that like this is not a possibility, this is also not a possibility, so it's got to be the infinite number of solutions possibility, because this is going to be a consistent system. It just has extra information. It has an extra equation that we technically don't need. Okay, so solve this system. So let's set this up the same way. We have 4x plus 4y is equal to negative 4, and we have 2x plus y is equal to 2. Let's, should we multiply the second one by 2 maybe? Let's multiply the second one by 2. That's going to make all of the x's equivalent to each other. So that would give me 4x plus 2y is equal to 4. And then what I'm going to do is I'm maybe going to add these, or sorry, subtract these from each other. So 4x take away 4x would be 0. And then we have 4y take away 2y, so we get 2y's. And then we get negative 4 take away 4 more for negative 8. Now I can divide both sides here by 2 to get y is equal to negative 4. And if y is equal to negative 4, we can grab this second equation, which to me seems like the easier one. We'll plug our value in for y, and we'll see what we get. So 2x minus 4 is equal to 2. So 2x is equal to 2 plus 4, which is 6. And then x must be equal to 3. So question 5, the admission fee at an amusement park is $1.5 for children and $4 for adults. On a certain day, 292 people entered the park, and the admission fees collected totaled $788. How many kids and how many adults were admitted? So there's two things I got to do here. So 292 people entered the park on this particular day. So the number of children, so let's go C for children, and let's go A for adults. We know that C plus A on this particular day was 292. Now, the other thing we want to keep track of is the price of a ticket for kids, price of a ticket for adults, and the total price. So we have $1.5 per child admission. We have $4 per adult admission. And all of this should add up to $788. So that's what we're looking for here. We can probably reasonably solve this one using substitution. So let's go C is equal to 292 minus A, and let's sub that into equation number 2. So 1.5 times C plus 4A is equal to 788. Hopefully we get an even number of children and adults, otherwise this would be terrible. Because you say Kramer's rule, get out of here. 292, what's half of 292? 292 times 1.5. So 438 minus 1.5a plus 4a. 788. So 4 take away 1.5 should be 2.5. And then I need 788 take away 438. 788 take away 438 should be 350. Now, hopefully 350 is divisible by 2.5. Please. Perfect. Okay, so A is equal to 140. There were 140 adults that came into the park. We do know that the total number of individuals was 292. So now we can take our 292, subtract our 140, and that'll give us the total number of kids that came in, which was 152. Beautiful. What quantity of a 70% acid solution must be mixed with a 20% solution to produce 900 milliliters of a 50% solution? I don't even know what this is asking. Who knows chemistry? Who knows chemistry around here? Help. I need to phone a friend. So it's almost like there's a certain, so we need to get 9, okay, so I think it's probably, it feels like something like this. And maybe I'm a little off here, but let's call S the 70% solution. And let's call T...
I don't need your guidance. I zeta understand this.
Oh, you know it works, okay. My intuition says I need the sum quantities to be 900 milliliters. And then I think I'm going to use your concentration question. I think that's what you're hinting at here. I need the... Have I set this up incorrectly, though? Because I need it to come out to be 50%, right? So it's almost like I need... Maybe this isn't two variables. Is this one variable? No, you're good. Okay. So S and T are in milliliters, though, right? Oh, okay. So concentration. So when it comes to... I need my output to be a 0.5% something. I don't know. Is that? So basically, we're taking the number of milliliters in the 70% solution. Because that's given in milliliters, right? I just don't know if I need to adjust this a little bit more, or if I'm happy with that. So 70%.
Is that a right I do?
Oh. Yeah. Units to yeah, exactly. Units to acid or something like that. So I think this is probably what they're looking for. And then they want us to solve this. Yeah, and I think probably what they want to say here is milliliters of the 70% solution. So yeah, I do agree with you there. So this is going to be 900 milliliters, isn't it? There it is. Okay. Holy cow. Got it. That was a struggle. Holy crap. Okay, so that should do the trick. Now, let's see if we can solve this and get something that actually makes sense. What is half of 900? I think that's 450, right? So let's just pop in 450. And then we can probably do substitution again, right? We can probably take equation number 1, which is S plus T is 900. And we could probably say that T is 900. Which one do I actually want to solve for? I actually want to solve for the 70% solution, so why don't we solve for S? And we'll say that that is 900 minus T. And then we'll bring our secondary equation down. So we'll have 0.7900 minus T plus 0.2 T is equal to 450. What is 70% of 900? 630. So 630 minus 0.7 T plus 0.2 T is 450. So that's going to give us negative... What, as long as I don't shouting... What? What am I shouting? Negative 0.7 plus 0.7. So negative 0.5 T. And then we need 450 take away 630. So 450 take away 630. That's going to give us negative 180. So this should divide nicely, I hope. So let's go 180 divided by 0.5, and that gives us 360. So we need 360 milliliters of the 70% acid solution in order to get the 900 milliliters of the 50% solution that we want. Holy smokes, that was an adventure, let's say. That was quite the adventure. You think 360 milliliters is my 20% acid solution? Oh, you're fucking right. What? That's right. Yeah, shit. Okay. Thanks, Luke. So that is correct. So 360 is going to be the 20% solution. But we can come back to this equation we have, which is the 900 minus 360, and that should give us our 70% solution, which should be 530. Does that sound right? 540. I'll prepare myself. I'll gird thy loins. Convert these equations in the system below to slope-intercept form, and then classify the system. What? Okay. Slope-intercept form of the first equation is going to be negative y is equal to x minus 2. So y is equal to negative x minus plus 2. Yeah, so negative x plus 2 I think is okay. So the second one is, this is weird notation, but let's go 2y is equal to negative 2x plus 4. And then we divide everything by 2 to get negative x plus 2. So we have two equations. They're the same equation, so one of them is redundant. So this is going to be a consistent, so it's definitely not inconsistent, and it's going to be consistent and dependent. I don't know if I've used this terminology before, but I know it's a consistent system because it is going to have a solution, and I'm pretty sure that y is going to be dependent on some parameter that we input for x. So I think we want consistent dependent here.